Okay. Okay, calm down, buddy. It's just a trial run for next night. It's not actually. Tonight, it's a special night. August 28, 2026. Write it down. Or don't, I'll remind you anyway.
Because tonight, 96% of the moon, 96%, will enter the darkest part of the Earth's shadow. Because this isn't just an ordinary partial lunar eclipse. Let's see together what awaits us on August 28th.
Because tonight, 96% of the moon, 96%, is about to slide into the darkest part of Earth's shadow. Okay, not yet, but it will. And here's where things get even more interesting, because this is not your average partial lunar eclipse. About 96% of the moon is going to enter Earth's umbra, which means only a tiny sliver of it will keep catching direct sunlight. And that is exactly why this eclipse is going to look so strange. Technically, it's partial, but visually, it's almost total. You don't want to miss this one. Because the next partial lunar eclipse is in 2028, and only about 7% of the moon will dip into Earth's shadow, compared to tonight's 96, and a much weaker eclipse on top of that. So basically, the moon is going to say, I'm staying out of this one. So don't miss August 28th. But wait a second, why does the moon sometimes go fully dark and sometimes only partly? And that red color, the one they call a blood moon, how does that even happen? Because before we get into that, we need to figure something out first. What even is a shadow? Let's break it down. Okay, let's handle the basics first. Question 1, is this going to be a blood moon? Short answer, no. But it's going to come very, very close. That famous deep red look people call a blood moon usually shows up during a total lunar eclipse. Tonight's eclipse is partial, but not just any ordinary partial eclipse. At maximum, about 96.3% of the moon's surface will sit inside Earth's umbra, the darkest part of the shadow. So a massive chunk of the moon is heading straight into Earth's dark shadow. And the part inside the umbra can look reddish or copper-toned because of sunlight bending through Earth's atmosphere. So technically, not a blood moon, but it's absolutely going to try to look like one. Question 2, when and where? And here's where it gets interesting. Because not everyone on Earth's night side sees a lunar eclipse the same way. If the moon is above your horizon, you get to watch it. If it's below your horizon, tough luck. The eclipse is still happening. The moon just isn't stopping by your place. Globally, it starts when Earth's faint outer shadow first touches the moon. That kicks off around 1023 UTC. But that stage is so subtle, it's genuinely hard to notice with the naked eye. The real show starts at 2034 UTC when the moon enters Earth's umbra. And it peaks around 04113 UTC. That's the moment when roughly 96.3% of the moon's surface sits inside the umbra. Then, the shadow starts pulling back. The partial phase wraps up around 05052 UTC. And finally, Earth's faint outer shadow completely lets go of the moon around 07002 UTC. Altogether, that's an eclipse lasting roughly 5 hours and 38 minutes. But not all of it is equally impressive. The real highlight is the partial phase, lasting about 3 hours and 18 minutes. So, what time is it where you are? Most of the Americas are pretty lucky here. They'll catch a large chunk of the eclipse, some regions, even all of it. Tile. Parts of Western Europe and West Africa will also get a solid stretch of it. But head further east into Europe and toward Western Asia, and things get a little sad. Because the moon will be nearing the horizon and setting in a lot of places before the eclipse reaches its strongest point. Take Istanbul, for example. The partial eclipse starts at 05033. By the time the moon reaches its highest point around 06026, it'll only be about 0.2 degrees above the horizon. So basically, right on the horizon. Istanbul. Buddy, I'm sorry. Still, it's worth getting up early just to catch the start. Most of Asia, Australia, and anywhere it's daytime during the eclipse, you're out of luck on this one. Good thing we invented the internet. So, you know your local time. You know where you can see it. You know how much of the moon will sit in shadow. But there's still one big question we haven't answered. How does Earth's shadow even reach the moon? And more importantly, why red? Let's figure it out. Okay, to understand this, we need three things: the sun, the earth, and the moon.
Oh no! Not the moon! Wait, stop! I have to catch it! Whew, I got it.
I should really be more careful with that. Now, the sun gives off light, and when Earth blocks that light, it casts a shadow behind it, just like you. Yeah, you cast a shadow too whenever you block light. Congratulations. You're applying the laws of physics. You can be proud of me. Not yet though. Now we put the moon into that shadow, and boom. Lunar eclipse. Easy. I could have done this in middle school. Probably. But now, the big question. If the moon is orbiting Earth the whole time, why doesn't this happen every month? Because the moon's orbit is tilted about 5 degrees relative to Earth's orbit around the sun. So most of the time, the moon passes above, or below the shadow. Basically, instead of getting eclipsed every month, the moon opts out. Respect. But sometimes, the sun, Earth, and moon line up perfectly. And that's when the cosmos goes, let's make some shadow happen. Lunar eclipse. There it is. But we've got a small shadow-related complication, because Earth's shadow, actually has two different personalities. The outer region is called the penumbra, the lighter shadow. Basically the version of a shadow that says, I won't fully darken you, but I will mildly inconvenience you. The darker inner region is the umbra, the serious one. The one that says, I'm here. No light gets through. Once the moon enters the umbra, that's when we start seeing the real partial eclipse. And on August 28th, a huge chunk of the moon is going to sink into that dark region, but not all of it, because this is a partial eclipse. Now here's where it gets genuinely weird. Let's say the entire moon slipped into the umbra. The sun can't reach it directly anymore, so the moon should, go pitch black. But it doesn't. Why is it red? Because Earth has an atmosphere. Yes, that blue stuff. Our atmosphere isn't just for breathing. Sometimes it lights up the moon too. Technically by scattering and bending some of that sunlight. Watch this. As sunlight passes through the atmosphere, different wavelengths behave differently. Blue and violet light scatter the most. Red and orange light pass through the atmosphere more easily. The atmosphere also bends the path of the light, so some of it curves around Earth's edge and reaches into the umbra, straight to the moon, and the result? A red moon. So, the reason the moon turns red, is us. Humanity strikes again. Okay, this time it's a good thing. That same physics is also why our sky is blue and why sunrises and sunsets glow red and orange. Light passes through the atmosphere. Some colors scatter more. And whatever's left changes color. Even how red the moon looks tonight is partly up to our atmosphere. Dust, aerosols, clouds, and especially particles from major volcanic eruptions can change things. Scientifically, that's really fascinating. For my nose, a little less fascinating. So different lunar eclipses can look different shades. Orange, copper, deep red, sometimes even almost brownish. So exactly which shade the moon picks tonight, even the moon won't tell us. Because the moon doesn't do weather forecasts. Anyway, you get it. Let's recap. The sun gives off light. Earth casts a shadow. The moon enters that shadow. Our atmosphere scatters and bends part of the light. And the moon turns red. Nice. But now, a genuinely important question. Do we actually need a telescope this big to see all of this? Or is just looking up enough? Let's figure that out too. Good news. You don't need any special glasses, filters, or eye protection to watch a lunar eclipse. Because this time, we're not looking at the sun, we're looking at the moon. So watching with your bare eyes is completely safe. Although wearing these does make me look cooler. Scientifically, absolutely no benefit. Bare eyes? Plenty good. Binoculars? Better. You'll see more surface detail and the shadow creeping across the moon more clearly. A telescope? More detail, more weight, and definitely more regret. But before any of that, check the weather. Because the eclipse itself doesn't care about clouds. But you should. Check the forecast for your area a day or two before the eclipse. Clouds in the way? Live stream it. NASA and various observatories broadcast the eclipse online so you can still watch, even in your pajamas. Science can genuinely be wonderful sometimes. And of course, photos. What is that? Is that the moon? No, that's a pixel. Do two simple things. 1. Keep your phone steady. Lean it against something or use a small tripod. 2. Don't overdo the digital zoom. Because your phone isn't zooming into the moon, it's just stretching pixels closer together. Now that actually looks like the moon. But hold on a second. Humans won't be the only ones looking up tonight. Some animals might notice the shift in moonlight too. For certain nocturnal species, how bright the moon is really matters, because suddenly the nighttime light changes. And, in some studies, nocturnal animals showed changes in their normal behavior during lunar eclipses. For example, in one observation of Azara's night monkeys, researchers reported a noticeable shift in feeding behavior during an actual lunar eclipse. So for the animal, it's basically, wait, why did the night suddenly change? But here's an important detail. This doesn't mean every animal is scared of the eclipse. In fact, some species might show no noticeable change in behavior at all. Because the reaction can depend on the species, its lifestyle, and its environment. But light matters, especially for nocturnal animals that rely on moonlight to guide their behavior. So which other animal should really be watching this eclipse? Some nocturnal animals have shown behavioral changes. But don't worry, there's no scientific evidence they're werewolves, at least, not yet. I'm still not going outside tonight though. Scientific precaution. Normally, night arrives gradually, the sun sets, the sky darkens, and animals' internal clocks can adjust to that steady change. But during a lunar eclipse, moonlight can shift relatively fast, which can briefly alter some nocturnal animals' behavior. So they might also look up at the sky and go, something's off, maybe, though we can't actually confirm they're saying that, because we couldn't get an interview. Okay, now we know how to watch it. We'll check the weather. We'll use binoculars or a telescope if we want. We know animals might notice this strange night too, and that werewolves are still scientifically questionable. But at the end of all this, we're really just watching Earth's shadow move across the moon, and that's exactly why you don't want to miss August 28th, because for the next truly striking partial eclipse, we're going to have to wait a while, quite a while actually. Okay, got everything ready. Binoculars, coffee, a blanket, an alarm, and most importantly, I am not going to fall asleep.
Hi! Don't forget to like and subscribe. See you in the next videos.